Sample paper 2023 and 2024 exams solutions physics. First we have to understand the physical constant and values. Speed of light c 3 into 10 power 8 meter per second. Mass of electron 9.1 into 10 power minus 31 kg. Electron 1.6 into 10 power minus 19 C. Permeability of free space mu naught is equal to 4 pi into 10 power minus 7. Planck constant H 6.63 into 10 power minus 34 joules. Relative permeability E naught 8.854 into 10 power minus 12. Avogadro's number 6.023 into 10 power 23 per gram mole. Section A. Which of the following is not the property of an equipotential surface? A. They do not cross each other. The work done in carrying a charge from one point to another on an equipotential is zero. For a uniform electric field, they are concentric spheres. D. They can be imaginary spheres. First, you have to answer this question. See, which is not the following is not the property of an equidistant surface. So, first we have to understand what are the properties of an equipotential surface. Equipotential surface. The electric field is always perpendicular to an equipotential surface. Two equipotential surfaces can never intersect. For a point charge, the equipotential surfaces are concentric spherical shells. The electric potential is the same at every point on the equipotential surfaces. They are imaginary spheres. Therefore, which is not correct is that they form concentric spheres, but they are rather than planes which are perpendicular to the electric field at that given point. So, answer is C. For a uniform electric field, they are concentric spheres is wrong. Second one. An electric dipole placed in an electric field of intensity 2 into 10 power 5 Newton per C at an angle of 30 degree experiences a torque equal to 4 nanometer. The charge on the dipole length is 2 centimeter is A 7 mu C, B 8 milli C, 2 mc, D 5 mc. Answer. Before answer the question, we can understand the question. Given torque T is Q, D is sin theta. Q is charge, theta is 30 degree. The distance between the dipole, that is 2a. Here given 2 centimeter, that is 2 into 10 power minus 2 meter. So we have used the formula. We get charge is equal to 2 mc. So answer is C. Question number 3. A metallic plate exposed to white light emits electrons for which of the following colors of light the stopping potential will be maximum? Blue, yellow, red, violet. Here, higher the frequency, greater the stopping potential. Therefore, red minimum, violet maximum. Here they are asking the stopping potential will be maximum. Therefore, answer D. D. Violet. Violet has maximum stopping potential. Question 4. When an alpha particle are sent through a thin gold foil, most of them go straight through the foil because A. Alpha particles are positively charged. B. The mass of the alpha particle is more than the mass of an electron. C. Most of the part of an atom is empty space. D. All the particles move with a high velocity. Explanation. Alpha particles contain 2 protons and 2 neutrons, that is helium. When alpha particles are sent through a thin metal foil, most of them go straight because most part of the atom is empty space. In other words, there is no obstruction in the path of the particle. So, our answer is C. Most of the part of an atom is empty space. So, most of the alpha particle go straight through the foil. Fifth question. An electron is moving along positive x-axis in a magnetic field which is parallel to y-axis. In what direction will the magnetic force be acting on the electron? A. Along negative side of the x-axis. B. Along negative side of z-axis. C. Along positive side of z-axis. D. Along negative side of y-axis. Explanation. Given an electron is moving positive side of the x-axis and field is parallel to y-axis. Asking force. Force is equal to Q into P cross B. Q is minus A, that is B. Velocity is x direction, that is I. Field is equal to y direction, it is J. So, V I cross B J. I cross J, we know that K. Therefore, minus E V B K. That is E V B minus E minus K. That is negative side of Z axis. Answer B. Negative side of Z axis. 6. The relative magnetic permeability of a substance X is slightly less than unity and that of substance Y is slightly more than unity. Options. A. X is paramagnetic and Y is ferromagnetic. B. X is diamagnetic and Y is ferromagnetic. C. X and Y both are paramagnetic. D. X is diamagnetic and Y is paramagnetic. Explanation. Permeability. In diamagnetism, which is less than 1, and paramagnetism, which is greater than 1, that is slightly greater than 1. Therefore, given X is less than 1 and Y is greater than 1, X is less than 1 means X is diamagnetic. Y is slightly greater than 1, therefore Y is equal to paramagnetic. Ferromagnetic have a very large permeability value. It is more than greater than 1. Question number 7. An ammeter of resistance 0.81 ohm reads up to 1 ampere. The value of the required shunt to increase the range to 10 ampere is A 0.90 ohm, B 0.09 ohm, C 0.03 ohm, D 0.3 ohm. Given that, see the diagram. Ig cross G equal to I minus Ig into stent. Therefore, S stent is equal to Ig current in galvanometer into G by I minus G. So, given Ig is 1, galvanometer is 0.81, then 10 minus 1 required. So, answer 0.81 by 9 is equal to, we get 0.09 ohm. Answer B, 0.09 ohm. 8th question. An electron with angular momentum L moving around the nucleus has a magnetic moment given by A. El by 2m, B. El by 3m, C. El by 4m, D. El by m. Answer. Magnetic moment mu equal to E by 2m L. L is the magnitude of the angular moment of the circulating electron around the nucleus. Therefore, answer A, El by 2m. 9. The large-scale transmission of electrical energy over long distances is done with the use of transformers. The voltage output of the generator is stepped up because of reduction of current. B. Reduction of current and voltage both. C. Power loss is cut down. D. A and C both. So first we have to understand the concept. The voltage output of the generator is stepped up because of reduction of current and power loss is cut down. Therefore, answer D, that is reduction of current and power loss of cut down. The reason is because the voltage is increased, the current decreases. Power loss is proportional to the square of the current. Power loss diminishes considerably as current drops. So, answer D, reduction of current and power loss is cut down both. Question number 10. The diagram below shows the electric field E and magnetic field B, components of an electromagnetic wave at a certain time and location. The direction of the propagation of the electromagnetic wave is A. Perpendicular to E and B and out of plane of the paper. B. Perpendicular to E and B and into the plane of the paper. C. Parallel and in the same direction as E. D. Parallel and in the same direction as B. Solution. Answer A, that is perpendicular to E and B and out of the plane of the paper. The direction of the propagation wave is C is equal to E cross B, that is modulus of E modulus of B sin theta n cap. The direction of propagation of the electromagnetic wave is always perpendicular to the plane in which E and B lies. B along the x-axis and E is along the negative side of y-axis. So, applying the right hand rule, the propagation of the electromagnetic wave is perpendicular to E and B and out of the plane paper. Therefore, solution A. Question number 13. Assertion and reason model. Assertion A. For the radiation of a frequency greater than the threshold frequency, photoelectric current is proportional to the intensity of the radiation. Reason or greater the number of energy quanta available, greater is the number of electrons absorbing the energy quanta and greater is number of electrons coming out of the metal. Explanation. When the frequency of the incident radiation exceeds the threshold frequency, the photoelectric current is proportional to the intensity of the radiation. As a result, the assertion is correct. As the intensity rises, so does the number of energy quanta accessible. By absorbing more energy quanta, a bigger number of electrons are emitted. A higher number of electrons equals to a higher current. As a result, the photoelectric current becomes proportional to the radiation intensity. So, the reason is also true and it adequately explains the assumption. Therefore, answer. Assertion and reason both are correct and reason is the correct explanation for assertion. Question number 14. Assertion. Putting p-type semiconductor slab directly in physical contact with n-type semiconductor slab cannot form the p-n junction. Reason. The roughness at contact will be much more than interatomic crystal spacing and continuous flow of charge carries is not possible. Solution. Both the assertion and the reason are correct and the reason explains the assertion. Explanation. A p-n junction cannot be formed by physically contacting a p-type semiconductor slab with an n-type semiconductor slab. The roughness upon contact does not match the interatomic crystal spacing of about 2 Armstrong to 3 Armstrong, resulting in a continuous charge is not possible. As a result, a continuous flow of charge carriers is impossible. Concept extrinsic semiconductor. 15th question. Assertion A. An electron has a higher potential energy when it is at a location associated with a negative value of potential and has a lower potential energy when at a location associated with a positive potential. Reason. Electrons move from a region of higher potential to a region of lower potential. Solution. A is true but R is false. That is, assertion is true but reason is false. Explanation. When an electron is at a location associated with a negative value of potential, its potential energy is equal to EV. So, from higher to lower potential, current flows conventionally. Electrons move from a lower to a greater potential when they flow in the opposite direction. Therefore, answer A is true but R is false. That is, Electrons move from a region of higher potential to a region of lower potential is wrong. 16th one. Assertion. Propagation of light through an optical fiber is due to total internal reflection taking place at the core cladding interface. Reason. Refractive index of the material of the cladding of the optical fiber is greater than that of the core. Here answer is assertion is true, reason is false. Explanation. Propagation of light through an optical fiber is due to total internal reflection taking place at the core cladding interface. Therefore, the claim is correct. That is, assertion is correct. The refractive index of the cable is interface of cable and air such that light always has total internal refraction. Since refractive index of the material of the cable of the optical fiber is greater than that of air. We know the requirements condition. One requirement for total internal reflection is that light goes from a denser to a rarer medium. Total internal reflection occurs in optical fiber as light passes from the core to the cladding. As a result, the core's refractive index should be larger than that of the cladding. As a result, the reason is untrue. For understanding, we want to know core or cladding. Optical fiber has two layers, one inner layer, next one outer layer. Inner layer is called cores. Data passes through the cores. Core is made up of dense glass or plastic. Outer layer is called cladding. It is also made up of glass or plastic. Cladding is used to the optical fiber to prevent any refraction while passing data. The function of the cladding is to provide a lower refractive index at the core interface in order to cause reflection within the core so that light waves are transmitted through the fiber. Construction of an optical fiber. See the figure above. Thank you.